I think you can start it.
Okay, so today we're going to solve a heap question called minimum operations to half the array sum. So we're given an input array. We want to choose one number, basically multiply it by 0.5, and then at the end, as soon as the sum of the input is equal to half, then we can return the number of turns it takes based on how many halves we have to create. So, okay. Let me think about how I want to approach this. So this seems like a heap problem because if we want to have something, then we want to half it, and then we want to make sure that the new half number is going to be most effective towards contributing to the minimum number of operations. Because if this number's half is now, wait, no, that's not the case. Okay, this number's half will always be bigger than this number's half, right? So, okay. So what we're actually going to do is we're going to make a heap and push all the elements into a heap and negate them because Python is min-heap. So as you can see, now we're going to have negative 19, negative 8, negative 5, negative 1. Okay? So, okay. Since we're looking for the half of the sum, we can probably get the total sum. So,
Can you explain the question first, and then you can start coding up?
well, you're just trying to find the number of operations to reduce the sum by half. Yeah, so.
Yeah, okay.
As soon as the sum becomes half, we're going to pop, and we're going to push, and we're going to pop, we're going to push. As soon as it becomes half, then we return our result. Yeah? So we want to count the number of turns it takes to do that. So for example, you pop 19, you push 9.5, you pop 9.5, you push 4.75, all the way until you get to whatever, like the total sum of here is like 24 plus 8 plus 1 is 33. So at least like maybe 17, 16, something like that. So yeah. And okay, so we're going to keep doing this as soon as the total sum is bigger than half sum. So, okay. So we're going to pop a value. And so we pop that value. Okay, cool. But because it's negated from the heap, we have to negate it back into a positive. And then now we can push back the half of it into the heap. So val to pop divided by 2. And obviously this is going to take one turn to do. Okay. So we also have to subtract because of this. So let's do total sum minus val to pop. And then total sum plus equal to whatever we're pushing back. To pop divided by 2 with parentheses. And then we just return the result in the end. There might be some bugs in this, but that's the general idea. Okay, so some bugs. There's an edge case. Okay, hold on, let's see. So there's something weird going on here. We don't even need to use a heap. We can actually just reverse our array input. Because a heap is supposed to be -8, -5, but I don't know why it's doing that. That's weird. So let's just sort the nums, and then for each number, I just basically want to change the order back. So yes, for each number, and I'll just print this out first. That should be fine. So print nums for n and nums. So now we have 19,851. So for each one, we can, yeah, we can just do this on each one, right? Just put this inside of here. So, okay, I see. Okay. 1 second. I'm trying to remember how I did this. We use a heap, but that's weird as to why this is showing like this. This is gonna take a while, but let me just think through this. So, okay. Why is our heap showing like this, though? That's the problem. Because this is a heap, but like... maybe we can run like heapify? Should not be the case. It should be -8, not -5, -8. Why is it showing like that? That's weird. You know what? Here's what we're going to do. We're just going to... okay, instead of doing this whole thing, we can just... for n and nums, then my heap dot append nums dot append n, and then we just reverse the heap. That should be better. But then we don't need all the negatives. This is going to time out. Oh, you know what? Yep, negative n. Let's try. I was still getting this. That's weird. Reverse equals to true. How about we just sort this? Not with true. Okay, that's a little better now, but... so we're just trying to pop 19 and reduce it to half. -19 times -1 is 19. And then, 19 minus this divided by 2, not... okay. Let's see. Oh, wait, no. I think it's supposed to push the heap. We're not supposed to add it back. Because if we add it back, we're not even... wait. Oh, that's weird. Wait, we're pushing onto the heap. So we already negated it. Now we need to do -1 times this one. There we go. Hopefully. There you go.
Okay.
So again, you see, this is the general approach and idea. So yeah.
Okay, can you tell me the time capacity?
Time complexity is O of n because we have to lift the input once. O of n log of n. So the total is O of n log of n because that costs extra. And then this costs like O of 1 time to pop and push to the heap. So it's still in the order of n. I think it's O of n log of n. I'm not sure. But
Yeah, I think, yeah. N log n, yeah.
And then space complexity is O of n because we have all these different lists that we need to store. So the heap itself.
Oh,
Yeah.
you could
An
end a
extra.
heap, right?
What?
You could create new array?
Yeah. The heap is a new array itself.
Okay.
Yep. So
Okay. I think it's good.